So here's my right triangle, by the way. I've noticed that mine always look like this, and everybody's consistent. They either always draw them this way or they always flip them around. Where's theta? Almost. Except for the right angle. So where do you want to put it? Do you like the bottom left? Okay, here's my theta. Now I'm told that the cosine of theta is -2/7. So what does that mean in terms of sides of my triangle? Adjacent and hypotenuse. What's the adjacent side?
The bottom one.
Okay, what's the number that I put there? No, I cannot put a negative number on a side. Lengths can't be negative, so what do I put there? 2. Here's my hypotenuse, what do I put there? 7. Keep in mind that your triangle does not ever indicate to you the sign of your function on the angle, because the triangle has to have positive sides. So all it gets you is the basic ratio, the sine of your sine, cosine, tangent, secant, cosecant, cotangent, whatever ones I remember in there, is determined by what's given in the problem when you figure out what quadrant the angle itself is in. All right, now what? Use the Pythagorean theorem. Okay, so what do you want to call this side? X? Okay. So according to the Pythagorean theorem, I have 2 squared plus x squared equals 7 squared. So that gives me 4 plus x squared equals 49. X squared equals 45. So x equals plus or minus the square root of 45. Which one is it and why? Why? Yeah, length is positive. So x is going to be the square root of 45, and so that's this one right here. But now I'm set to actually do everything I need to do. Sine of theta according to the triangle, what's the ratio I start out with? Okay, so that would give me square root of 45 over 7. Oops, my square root didn't get big enough. And is it positive or negative? Well, I do the same thing that I did in my circle picture, in my circle part, to determine whether I'm positive or negative. I have to figure out what quadrant this is in. And we went through how to do that, so we know that we're in quadrant 2. So I might write that up here at the top. I'm in quadrant 2, and that's going to make a difference for all the signs that I put in. Okay, so in the sign, we positive or negative in quadrant 2? The sign of theta, will it be positive or negative? Positive? Okay, I'll go for that. What's the next one? Then my cosecant of theta, I can either look at my triangle or I can take the fact that I already have the sine of theta. What do I do with the sine of theta to get to the cosecant of theta? Flip it over. So it would be 7 over the square root of 45, excuse me. And I don't have to worry about the sign, S-I-G-N, changing, because when I flip something over, it doesn't change the positive or negativeness of it. What about my tangent of theta? Well, this is one where I could either use the fact that I've got the sine and the cosine and put them together, or what sides do I put together to find my tangent? Opposite and adjacent over each other, so I get the square root of 45 over 2. I'm in quadrant 2. What can you tell me about my tangent in quadrant 2? It's negative. What other clue would there be in this problem that you needed to have a negative sign in front of that answer? Nope.
Less than 0.
Yeah, I'm told my tangent has to be less than 0 in the problem. So it darn well better have a negative sign in front of it when I write the answer down. What about my cotangent of theta?
What's it?
Negative 2 over 40, square root of 45. And secant, well, I just did this one. I took my cosine and flipped it over. So negative 7/2. Easy enough? Yes?
On the test, are you ever gonna like tell us to do it one way or the other? Or just,
No.
Okay.
I find that most people use the triangles, and that's fine, you just gotta remember all the pieces of it. So the big thing is, don't forget, lengths can only be positive, and you should tell me what quadrant you're in to justify all your SIGN signs. But after that, I don't care. Some people use this, but it's rare. Not quite sure why, but I know it is. We just did something like this, and we won't do this one again. Oh, no, we will, we will. I have a question for you, now that I remember what this problem is. This is a big problem. If the cosine of theta is 6/8, and theta is in quadrant 4, what is tangent of theta times the cotangent of theta? How many of you want me to draw a triangle to work on this? How many of you want me to use my unit circle to work on this? How many of you think I can do this without doing either of those? I like these guys. Why can I do this without answer this question without actually dealing with the fact that the cosine of theta is 6/8?
Because they're inverses, and if you multiply them, you're going to get 1,
Yeah.
depending
So
on what
this
quadrant you're in.
What is the tangent of theta times the cotangent of theta? And you want to be careful about calling them inverses.
Yeah.
You need to specify which type of inverse they are.
Okay.
But what was one of the definitions of the cotangent of theta? What was that? It was equal to what?
Whatever.
1 over the tangent of theta. And when I take the tangent of theta and multiply it times 1 over the tangent of theta, what do I end up with?
1.
1. Every time. So I didn't need a triangle to do that one. Let's see if the next one needs a triangle. Or a circle.
Is it a negative 1?
No, because tangent and cotangent would have the same sign,
Oh, okay.
and so the negative divided by negative would be a positive. Even though both would be negative in quadrant 4. Cosecant of theta times the tangent of theta. Do I need a triangle for this one?
Nope.
You're comparing yourself to like those things, maybe like,
Identities?
yeah, we had like reduce it, like get it.
Yeah. Yeah, do it all in terms of sines and cosines. Yeah, this is setting you up for that, but you know, we don't do identities until the beginning of chapter 5. So we have to get through 4, 5, 4, 6, and 4, 7 first before we get there. But yeah, it does kind of get you used to that idea. Okay, so we got at least one person who votes that I don't need any triangles for this. What is the cosecant defined as? 1 over which one? The sine of theta. And what is the tangent of theta defined as? Sine of theta over the cosine of theta. So when I multiply those two together, what do I get? 1 over the cosine of theta. And what would that value be? 8 over 6, because the cosine of theta is 6 over 8, so this would be 1 over 6 over 8, which is 8